Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have more than 14 years of work experience in the fields of artificial intelligence, software development, and robotics. This video is part 3 for Pathfinder AI project. Let's continue. Action selection and model optimization. This policy is used for exploration. The optimized model function retrieves a random batch from memory and trains the policy network. So let's see this code. What this is: choose action, optimized model. So these functions are key part of the agent's learning process. They handle action selection based on the exploration exploitation trade-off and the training of the policy network using experiences stored in memory. So let's see what this code means. So the function decide which action the agent should take based on an epsilon greedy strategy, balancing exploration. What this means: random actions. As you can see, it is taking random actions, and exploitation using the learned policy. So as you see, over time it starts to learn the path where it should go. So this is what it is doing. It is taking random action for the exploration, and using the learned policy, it is keeping the things in the past in the memory in the neural network DQN, and using that it is next time it is moving on the correct path. So if random dot uniform 0 1, what this means is, with the probability defined, the agent takes a random action. This promotes exploration, especially in early episodes, to help the agent discover effective move. And random dot choice, what this is doing is, if exploring a random action 0 to 3 correspond up, down, left, right. This is what random choice is. So random dot choice, it will choose from only 4 values: up, down, left, right, and from 0 to 3. So range 4 means it will 0 to 3, it is from 0 to 3. Else, if not exploring, the agent uses its policy network to exploit learned values, state underscore tensor. So what this means is, convert the state into a tensor and adds an extra dimension for batch processing. So tensor is the format that is used for training the models effectively, because it helps in faster processing when we use when we are training machine learning model. So the complex version of a list of an array. Okay, and as I told you, multiple dimensions. So 0 dimension, 1 dimension, 2 dimension. So what are the technical terms? Scalars, this is 0 dimensional tensors. Vectors are 1 dimensional tensor. Matrices, as you know, matrices in through mass, like a table of numbers, are 2 dimensional tensors. And there are higher dimensions like 3D, 4D, etc., represent even more complex data structure, like multiple images or batch of data for training a neural network. Tensor are main data structure for TensorFlow, used to store all the inputs, outputs, even intermediate data in machine learning model. And they are faster because we are computing so much data. So they are faster than other data structures. They make it easy for TensorFlow to perform with math operation on large amount of data. As you know, we are dealing with large amount of data. To create a machine learning model, you will be dealing with 50 GB of data, 1 TB of data. For that kind of computations, you will require something that can compute on that level and efficiency. So tensors are those things that you require for those kind of computations. So let's see. I told you this because everywhere here it is writing tensor, and you should understand what tensor is. So let's see here. Converts the state into a tensor and adds an extra dimension for batch processing. So now you understand what extra dimension means is, in tensors you have multiple dimensions. So q values, policy underscore net state underscore tensor feeds the state through the policy network to get q values for each action. And this one, torch argmax, chooses the action with the highest q value, representing the agent's best estimated move. And here we are using torch to train our neural network. If you remember, we are using torch to train a neural network. So for optimizing model part, let's see. Okay, so what this means is, as you can see everywhere it is written tensor, 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 tensor. So you understand this. So this function trains the policy network by sampling from the replay memory, calculating loss and performing backpropagation. So if this is the code, so returns immediately if there aren't enough experience in the memory to form a full batch. Randomly samples a batch of experiences from memory to reduce temporal correlation and improve training stability. And what this means is, as you can see in the code and understand, unpacks the batch into separate lists for states, actions, rewards, next states, and done flags. So with the name you can understand what it contains is. So the tensor conversion, each list is converted into a tensor for PyTorch compatibility. So everything we are getting are being converted to tensor so that we can run it through a neural network. So current and target queue values calculations. So current queue values, policy underscore net, states underscore tensor, gather. Okay, so compute queue values for the action taken in each state, retrieves queue values specifically for the actions chosen in memory. Again and again, what actions are up, down, left and right. And when it is talking about memory, I told you many times, this is how it works. It keeps things in the memory, DQN. So this code will compute the maximum queue values for next states using the target network. And what this code will do is calculates target queue values based on the Bellman equation. The reward is added to the discounted maximum future queue value, adjusted if the episode is okay. So you don't have to go into too much detail. Let's see this training loop, how it is working and what this is. So this is the training loop, and this is very main part in this code, because this is what is moving that moving everything and doing everything. This is the training loop. And let's see the number of episodes. Okay, so the number of episodes given are 1000, so it will run 1000 times. Okay, so this is what is doing, number of episodes. So in each episode the agent starts at an initial position. As you can see, after reaching the position, it will start from initial position and explore the environment while updating its policy and target networks. So let's see outer loop, episode iteration for episode in range, loops over a set of number of episode. Each episode represent a full attempt for the agent to reach. So it will take full attempt to reach the goal and not stop in between. So as you can see, it starts from there and goes until it reaches the destination. Okay, so this is what is happening. So initial state is 0 0, this is the start position. Inner loop for this controls the maximum steps allowed per episode. This prevents the agent from taking excessive step. So let's see this one, how much I have defined. So 100, not more than 100 steps it can take to reach the destination. Action choose underscore action chooses an action based on the current state. And epsilon greedy strategy, explore versus exploit. New state, reward, done. You already understand this with the name, what it is doing. Memory append adds a current experience to the replay memory. So this is the replay, it is keeping everything in the replay memory so that it will learn from the previous or past experiences. It is keeping everything in the replay memory. So memory.append, so I must have declared the memory somewhere in the code. So let's see, this is the memory, max length is 2000. Okay, so I have mentioned the memory also, how much it can keep in the memory. Optimize model calls the function to train the policy network using a batch of experiences sampled from the memory. Update state is equal to new state, updates the agent state to a new position for the next step. and episode completion is if the agent reaches the goal. So it is not necessary, it has to so when it reaches the goal, that is the green part, it will just break the for loop. As you know, when we use break statements, it will break the for loop or while loop and stop the execution, and then it will again go for the next one. So this is one this is the thing what break statement is comes. It will stop the execution and take out of the loop. So if the agent fetches the goal, the inner loop breaks and the episode ends. So there are, I think, two loops. See, there are 1, 2, 3 loops. So when I use target network update, so if episode is this, every 10 episodes the weight of the policy net are copied to the target net, stabilizing training by making the target network less frequently updated. As you can see, over time it will start to get to the right position, and again it stopped because it has completed the steps or the training process I given. I think I gave 1000 and it has completed it, so it stopped. So what this is, after each episode is epsilon is decayed by multiplying it by this, gradually reducing exploration in favor of exploitation. The max function ensures it doesn't fall below a minimum threshold, maintaining some exploration throughout the training. So it will explore new paths again and again to reach the destination fast and more effectively. So this is the complete code, and I told you each and every line how it works. This video marks the completion of AI Pathfinder project. See you in next session. Have a nice day.